Hello everyone. As you know, we are dealing with the preparation methods of phenol. Two already we have done, Dow's process and reaction of benzene with propene. It's a time to understand third preparation method of phenol, which will be done from phenyl magnesium bromide and oxygen gas. Mechanism of the reaction is not involved in the 12th class. It is for JEE, NEET and B.Sc. First, let's check what that reaction is. Actually, that reaction is completing in 3 steps. First, this is phenyl magnesium bromide. Actually, it's nothing but a Grignard reagent, RMGX, where R is benzene ring here. Already we have discussed in previous videos. Between magnesium and bromide, there is an ionic bond. Between magnesium and carbon, there is a covalent bond. Sharing of electron is there. These two electrons out of magnesium and carbon, which is more electronegative, carbon is more electronegative, so electrons are more toward carbon side. So carbon is partially negative and magnesium is positive here. We will pass oxygen gas from it and heat. Liquid magnesium bromide will be there, phenyl magnesium bromide will be there. We are going to heat it with oxygen. So first, this intermediate will generate this one. We call it phenyl peroxy magnesium bromide. Peroxy because two oxygen atoms are there. It's a peroxy. Between this oxygen and this magnesium, ionic bond is there. And between this oxygen and this carbon, covalent bond is there. This is the first step. Now secondly, this intermediate which is generated over here, phenyl peroxy magnesium bromide, will react again with another molecule of phenyl magnesium bromide. It will be your second step. Here I am writing. It will react again with second molecule of phenyl magnesium bromide, due to which it will create this compound. Phenyl oxy magnesium bromide. Two particles will generate phenyl oxy magnesium bromide. Now this will be the second step, and in third step, the compound which is generated here, a white crystalline particles they are, we are going to acidify them with the help of dilute HCl. We will mix dilute HCl in them. This will be your third step, which finally gives phenol and basic magnesium bromide. This one. Phenol will be generated and basic magnesium bromide will be generated. In 3 steps, that reaction is getting completed. First step, this one. Second, phenyl peroxy magnesium bromide will react with another molecule of phenyl magnesium bromide to create 2 molecules of phenyl oxy magnesium bromide. Only one oxygen is there, so oxy magnesium bromide, which on further acidification with dilute HCl will give us phenol and basic magnesium bromide. Why we are calling it basic? Because OH will be connected there. Now for 12th class, these reactions they have to learn. Students have to learn these reactions. So what tricks we can make for that? Simply like O2. O2 you have to just insert between carbon and magnesium. Or you can learn it like this: between magnesium and bromide, ionic bond is there, so difficult to break. Ionic bonds are stronger as compared to covalent bond. So break covalent bond and fit your oxygen here like this. So automatically you will come to know, you can remember it, how to fit oxygen. A shortcut trick it is, it's not a mechanism. And here as you know, this oxygen and this carbon, out of these two, which is more electronegative? Oxygen is more electronegative, so it is carrying a negative charge, partial negative. This carbon carrying a partially positive. And here, like this magnesium is carrying positive charge, and this carbon is carrying negative charge. So you just have to add this magnesium on this oxygen. Break bond from here, like this, and this OMgBr you will join with this carbon, like this. So two particles of phenyl oxy magnesium bromide will generate. Simply learn, this is a negative oxygen, and here we have Mg as a positive, MgBr, the full particle. You will attack on this oxygen, you will break bond from this oxygen, and OMgBr you will join on this carbon. So two particles of phenyl oxy magnesium bromide will generate. And on dilute HCl reaction, as you know, HCl will give you H positive and Cl negative, and here oxygen is carrying negative. Between oxygen and magnesium, ionic bond is there, it is positive. Oxygen is negative, magnesium is positive. So this H positive will attack on oxygen, so OH will generate, and Cl negative will attack on H positive. Okay, wait. Hydrolysis, dilute HCl, hydrolysis will happen. Hydrolysis means H positive and OH negative. H positive and OH negative. H positive will attack on O negative, and OH negative will attack on Mg, this one. Because in dilute HCl, water particles are also there. So water particles are breaking into H positive and OH negative. Cl negative particles are very less because it's a dilute HCl. So H positive, OH negative will attack. H positive, OH negative, and finally you will get phenol and magnesium hydroxybromide. Now let's check what is the actual mechanism of a react. To understand mechanism, every step we have to open. Let's start the very first step, where phenyl magnesium bromide is reacting with oxygen, which we call aerial oxidation also, to produce this intermediate phenyl peroxy magnesium bromide. The reaction is happening with free radical mechanism. Free radical mechanism. And which is SET mechanism. SET means single electron transfer mechanism. Look how it is happening. We can call this mechanism also free radical insertion. Free radical insertion mechanism, because this oxygen as a free radical will insert between carbon and magnesium. So let's check. Initially, between carbon and magnesium, bond will break like this. So, Mg Br, this free radical, and this phenyl free radicals will generate this one. Now, because Mg is a good electron donor, as you know, it's an electropositive metal, it can donate its electron very easily. And oxygen with a very high electronegativity, oxygen gas, I am writing here. Oxygen atoms are highly electronegative, so it will transfer its one electron to any one atom of oxygen. That's why we are calling it SET, means single electron transfer mechanism. Suppose this oxygen is getting that. So what this oxygen will do, it will break its pi bond, because for one unpaired electron, one more unpaired electron is required, like this. So it will turns to total how many pairs will come? 2 already are there, 3 will become. with a -1 charge, because this electron was the extra electron from the magnesium side. And what about this oxygen? This oxygen will be neutral oxygen with 1 unpaired electron, this one. And this magnesium bromide will turns to, in this magnesium bromide, already magnesium is carrying +1 charge, which was balanced by -1 charge of bromide. Please check previous videos where we have discussed Grignard reagent. And when it will lose one more electron, the total charge will come on it will be +2 and Br negative as it is. So obviously this +2 cannot be balanced by only a -1. So for this +2, -1 will be required, that is here. Means this Mg is going to combine with this oxygen, and which bond will generate? Obviously ionic bond will generate between them. What about this unpaired electron on this oxygen? It's a free radical, can be stabilized by a free radical. Here we have a free radical, phenyl free radical. So in this fashion, it is going to combine it. And finally, after every joining, we will have this with us. Single electron covalent bond. This oxygen is connected with a single bond with this oxygen, carrying negative charge, which is balanced by Mg +2 Br negative. So +2 charge of a magnesium is balanced by 2 negative charges. So this. Now this intermediate is known as phenyl peroxy magnesium bromide. So this is a first step mechanism, which we call single electron transfer free radical insertion mechanism. Now let's go for the second step of the reaction, in which this particle is going to react with another particle of phenyl magnesium bromide. Second step. The second step was in which I said this one particle of phenyl peroxy magnesium bromide is going to react with another particle of phenyl magnesium bromide and will give you two particles of phenyl oxy magnesium bromide. This is phenyl, this is oxygen, so phenyl oxy magnesium bromide. Now how that reaction is happening? Very easy, but some points are there which we need to understand. In phenyl magnesium bromide, as you know, magnesium is carrying positive charge, and this carbon to which it is connected, as it is more electronegative than magnesium, so it is a partially negative carbon. It's a negative carbon over here. And here, phenyl peroxy magnesium bromide. Let me tell you what point we need to understand here. Actually, two oxygen atoms are there. This we call internal oxygen and this we call outer oxygen. Now you can check, internal oxygen is directly connected with benzene ring. So obviously it is showing resonance with it. The students who have a knowledge of resonance can easily draw resonance of it. Means pi electrons are delocalizing over entire benzene ring like this. Further structures please draw by yourself. Now when it will show resonance, actually what will happen on it? It will make double bond with a phenyl and will carry a +1 charge. I have not drawn all the resonating structures, please draw by yourself. The main point I am telling, this oxygen will carry +1 charge due to resonance. As it is carrying +1 charge, so what will happen? It will start attracting electrons from this side, making this oxygen electron deficient. This is the main point. No doubt this oxygen is carrying lone pairs, 3 lone pair, -1 charge is there, but that -1 charge is stabilizing this magnesium also. and its neighbor oxygen, due to +1 charge, is attracting electron density toward itself. That's why this terminal oxygen, this outer oxygen, will be a electron deficient. Means it has a shortage of electron. From a very first look, it will never look like an electron deficient atom. Means who have a shortage of electrons. But when we will check it properly, we will find its neighbor is creating problem for it. This neighbor. The neighbor is busy in resonance, due to which it is carrying a +1 charge, and that +1 charge is attracting electrons toward itself. That's why this oxygen is becoming little electron deficient. Now this deficiency of electron will allow to attack it on this carbon, negatively charged carbon. And obviously when it will attack on this carbon, electrons will completely transfer toward this oxygen, like this. Between magnesium and bromide, bond will break and both electrons will come toward carbon, because carbon is more electronegative than magnesium. So please check what will happen if I write it properly. Okay, once I am rubbing this resonance, I am drawing normal oxygen. Already we have understood the reason. This oxygen is positively charged due to resonance. Once we have understood, no need to draw it again. Now this is positively charged, and this oxygen will break bond from this oxygen and electrons will completely shift toward this oxygen. So this part will become negative, because when bond will break, electrons will completely shift toward this oxygen, and this oxygen with its vacant orbital will attack on this carbon, and carbon will break bond from magnesium. So between this oxygen and carbon, a dative bond is going to generate. Now please take care with charges. Look, when this electron will completely transfer toward this oxygen will have a shortage of one electron. So once it will become neutral, this -1 charge will be finished. But as it will make bond with the carbon, carbon will provide extra electron of the magnesium to it. Again it will become -1. A dative bond is there. So this electron was delivered by carbon to it, and this electron was of magnesium. So it will get again an extra electron and it will again become -1. So in this fashion, first OMgBr molecule will generate. Now look here, O-1, this part is generated. From where it will get MgBr? Obviously from here. Mg has lost its electron, it will become +2. Again +2, -1 cannot balance each other. So that +2 magnesium will attack on this oxygen like this. Means it is going to attack on this oxygen. So two particles of phenyl oxymagnesium bromide will generate. This is the mechanism here we have for conversion of phenyl peroxymagnesium bromide intermediate to phenyl oxymagnesium bromide. Now last step, very easy. The third step. The third step involves hydrolysis, and already we have discussed what is hydrolysis. This is negative, this is positive. Hydrolysis means breaking bonds between atoms with the help of H positive and OH negative. From where we are getting them? We are getting them from dilute HCl. Dilute HCl means lot of water is available there and very less amount of acid is there. So this water will break in H positive and OH negative particle. This will also break in H positive and a little bit Cl negative particles will be there. So OH negative amount and H positive amount is higher. So what will happen? This H positive is going to attack on oxygen, because between oxygen and magnesium ionic bond is there and oxygen is carrying complete negative charge. And this OH negative is going to attack on Mg. Between them bond will break, ionic bond will break, and finally we will get phenol, and this Mg BrOH. That's it. This is the mechanism for preparation of phenol from phenyl magnesium bromide and its aerial oxidation. Aerial oxidation means we have to pass oxygen directly from the liquid. We will bubble the oxygen gas from that liquid and we will heat it, and then further process will start like this. That's it. This is the end of the video. In next video, we will cover next preparation method of phenol. Thank you very much for watching the video.